Hello everyone, welcome back to the science class. Today we are going to discuss a new topic, that is sound. So, what is sound? Sound is a form of energy which gives sensation in our ears to hear it, right? So basically we hear a sound with our sense organ, that is ears, right? And sound is a energy. Sound is a form of energy like heat and light. You are very familiar that word energy and energy are of various types like light energy, heat energy. In the similar way, sound is also a energy, is a type of energy. Sound help us to communicate. Sound help us to communicate with each other, to express our feelings, to express our words. We use sound. How? See. Did you get what I say? Yes, I know. You don't get my words. What I want to say. Just because there is no sound in this clip. You see, there is no sound in this clip. So you don't get my words. So without sound, we can't communicate with each other. You see that? Without sound, we can't communicate with each other. Now, how this sound is produced? Actually, sound is produced due to vibrations. Means when we hit anything, like we do clap, like that, it produces sound, right? When I meet my hands with in this way, it makes a sound. So from that you conclude that a sound can be produced only when an object goes forward and backward. Forward and backward, forward and backward. And this forward and backward movement is known as vibration. See, sound is produced due to the vibrations of object, right? The to and fro motion of objects are called vibrations. That to and fro motion means that forward and backward motion, forward and backward. This type of motion is called vibration. You are very familiar with that vibrations. You see vibration in your phones, and similarly, if you take a hammer and take a metal object and then you hit it, you see a sound is produced just because of the vibrations. Because when we take our hammer to backward and then forward, backward and then forward, it will produces sound. So now you get 2 points, that sound is a form of energy and sound is produced by vibrations. Now you see that humans also produces sound. Not only humans hear sounds, but also humans produces sound. Okay. Humans also produces sound. In humans, sound is produced by larynx or voice box. Basically, think that sound is a form of energy. And from where does we get that energy to produce sound? So we eat food, right? And food is converted into energy, and then it produces a sound. It helps us to produce sound, and sound help us to communicate. Now, in humans, sound is produced by larynx or voice box. Sound is produced by voice box. Actually, we have a windpipe through which air passes. And on the top of the windpipe, we have larynx or voice box, which produces sound. Voice box is at the upper region of windpipe. Voice box is situated at the upper region of our windpipe. There are two stretched membranes called vocal cords attached in larynx with a narrow slit between them. Actually, a voice box has two stretched membranes that can able to be stretched. Okay, remember that vibration which needs forward and backward movements. That's why our vocal cord has two stretched membranes. Okay, which can move to and fro. Okay, which can be actually the membrane goes loose and tight, loose and tight. That produces the vibration. in larynx with a narrow slit between them, and these membranes are attached with a narrow slit with a narrow layer of skin. Our vocal cords attached with muscles, so it has a stretching membranes, hence the attached muscles make it tight and loose. Our stretched membranes are attached with muscles. Our muscles, you know very well that what are muscles. So the stretched membranes are attached with our muscles, so as to that stretching properties, they can be loose or tight to produce sound. We produce different quality of sound by this loose and tight phenomena. And as you know that human can produce a wide variety of sound. We can sing, we can shout, we can cry, we can laugh, we can whisper also, right? So as to we say that humans produces a quality of sound. Now let us see propagation of sound. Now what does that word propagation? Propagation means traveling. That how sound travels. So the traveling of sound is called propagation of sound. Get it? That the traveling of the sound from one person to another or from an object to our ears is called propagation of sound. The sound needs a medium to propagate like solid, liquid and gas. And the most important thing that sound can't be travel without a medium. Sound travels only in a medium, like we communicate with each other through a medium that is air. That there is air present in my room, and I can produce a sound and which can be traveled through air, because air is a mixture of gases. Sound needs a medium to propagate like solid, liquid and gas. Sound can't travel in vacuum. Sound can't be traveled in vacuum. So as to you get that, propagation of sound is the traveling of sound, and a medium is necessary for the traveling of sound. So as you get that, sound needs a medium to propagate. Now see how sound travels. Sound travels in the form of wave. Sound travels in the form of wave. What is wave? Wave is a disturbance that moves energy from one place to another. Wave is just like that, and wave is a disturbance which transfer one energy to one place to another. They are of two types. Waves are of two types, longitudinal and transverse waves. And in this chapter, we are going to study the longitudinal waves. Longitudinal waves are also known as the sound waves. Actually, what happens? Suppose you rang a bell. When you rang a bell or you utter some word, suppose you utter some words, and you see that when you utter words, then your sound moves in the form of vibration. The particles near your mouth start vibrating, and thus they start vibrating. They move another further particles to starts moving and cause vibration, and further vibration causes the sound to reach the ears of another person. What will you get? That when we say anything, the particle near our mouth are starting vibrating, and after that the particles are further vibrating, and this motion of vibration continues till the sound reaches the ears of another person. See, suppose this is a bell and it rang, and this is the process of the vibration of particles. See, there is dense particles, there is dense particles, there is dense particles and dense particles, and they are light particles. So what does it mean? That they start to and fro motion, to and fro motion, and after some time they the particles reunite, and then after to and fro motion, then to and fro motion, and this type of a complete wave in the particle form makes. How sound propagates? Actually, when we ring a bell or we hit anything with suppose we hit a bowl with a spoon, then it produces sound. Then what happens? The particle near that object start vibrating in to and fro motion. Just like that. And this type of motion is called what? Are longitudinal wave. The particles here are dense, dense and dense. So as this wave. The dense part of this particle is the crest and the light part of this particle is the trough. Its length is according to the pitch of your sound. How loud your sound? See, a wave may be a long wave and a wave may be a short wave just because of your pitch of the sound. That is how loud you say. When you say louder, then it will be like that. And when you say in a whisper method, in a whisper manner, then this is the wave. See, a wave has some parts where see the term related to the wave. That is wavelength, crest, trough, amplitude. What are these terms? First, wavelength. The distance between two crest or two trough. This is crest, the upper region, and this is trough, the lower region. The distance between two crest or two trough is known as what? Wavelength. And crest is the highest peak of your pitch and trough is the lowest. And amplitude, what is amplitude? How shrill or how loud is your voice? According to the loudness of your voice, the amplitude is that. This shows the loudness of your voice. This is the amplitude. When you talk in a very polite or in a very low manner, with a low voice, then the amplitude is just like that. And when you utter some words very loudly, then the amplitude is like that. I hope you all got that point. That is what is crest, trough, amplitude and wavelength. For example, let us do an activity. Touch your phone speaker and look, what will you feel? You feel the vibrations of my sound. Really? You got the vibrations of my sound? That is why, because sound waves are moving in a vibrating manner and they reach our ears by vibrations. Got it? That sound wave is moving like a vibration and the particles move in to and fro motion. As you know that sound needs a medium to propagate. Sound can't be travel in a vacuum. Now see how sound travels in different kind of mediums like solid, liquid and gas. Actually sound propagates much higher in solid and then after in liquid and then gas. That means very low in gas. Suppose you have a table and you hit it with your hand and somebody put his ears right over there. Then he feel the sound's vibration much higher than in liquid or gas. And similarly, if you put a bell in a water tumbler, you take a water tumbler and fill it with a water. And you see that when you ring a bell in this, you put a bell in it and you ring it with your hand. And you see that if you put your ears here, you put your ear here and you feel the sound much higher than you feel in the air. Suppose you have a bell and you rang it in the air and you rang it in the water, then this sound is different. Yes, different, but much louder than in air. So we can say that sound propagates higher in solid, then liquid and then gas. But sound can't travel through vacuum. Sound does not travel in vacuum. Now let's see designing of human ear and the functioning of human ear. How do we hear sound? See, this is our ear. The ear has three parts: outer ear, middle ear and inner ear. Outer ear consists of pinna, Auditory canal, eardrum. Pinna. See, this is pinna. The ear you saw is pinna, the outer part. And when a sound travels, you have to see there is a hole and it reaches to our eardrum, the canal. That is a canal which we call auditory canal. Auditory canal. And afterwards, here is eardrum or tympanic membrane. We call eardrum tympanic membrane. So we have three parts in outer ear: pinna, auditory canal and eardrum. When we hear a sound, it comes into our ear and reaches to the eardrum through the auditory canal. And afterwards, it reaches to our middle ear. See the middle ear? Middle ear has also three parts, that is hammer, anvil and stapes. These are three bones. Also they called malleus, incus, stapes. Malleus is hammer, incus, anvil, stapes, stirrup. Now see, when sound came to the eardrum creates vibration. In eardrums there will be vibrations, and so as that hammer is attached to the eardrum, and anvil is attached to the hammer, and stapes is attached to the anvil. So the vibration reaches to hammer, then anvil and then stapes. And the function of these hammer, anvil and stapes is to increase the amplitude of that sound. The three bones increases the amplitude of that sound. And this stapes is connected to the oval window. That is oval window, which actually take this vibration to the cochlea. Cochlea is you see the spiral. Actually, this is the inner ear part, cochlea and auditory nerves. When the sound came into our ear and hits the eardrum, and then eardrums transfer its vibration to hammer, anvil and stapes, and these three bones increase the amplitude of your sound, and after that it reaches to the cochlea, and cochlea send it to the auditory nerve. And auditory nerves brings that sound to the brain. And hence these auditory nerves, actually cochlea converts our sound into the electrical signals, and then these electrical signals are carried out by auditory nerves to the brain, and brain actually got what the sound came, and we hear the sound, because you know that brain controls all the activities of our human body. Brain controls all the activities of human body. So as the signals send into to the brain, and then we hear any kind of sound. So now you get what is the working of your human ear and how we hear sound. Got it? Now let us see some more terms related to sound, that is amplitude, time period and frequency. So students, what is amplitude? You know very well that amplitude is the distance or displacement that particles can travel in a wave. This is amplitude. The louder your voice, the maximum the amplitude, and the low pitch of your voice produce the lower amplitude. This is amplitude, and it is represented by A, and its SI unit is meter. Yes, and between the two higher amplitude there is wavelength. What is there is? Wavelength. The top of the amplitude is called crest, and the lower part of the amplitude is called trough. So the distance between two crest or two trough is called wavelength, and we represent the wavelength by lambda. This is lambda. Okay. Now see the frequency. The number of vibrations or oscillations. Vibrations or oscillation. Oscillation is related terms to the vibration. That means one oscillation means the one displacement. Suppose you have a pendulum and you hit the pendulum, and the pendulum is at the mean position and you hit it right away. the maximum this displacement in 1 second. The oscillation or the vibration in 1 second is known as the frequency. Let us understand it by two waves. See, the first wave has what? A small amplitude, and the second wave has higher amplitudes. Now you see that in this case the frequency is very low, because in 1 second, suppose this is 1 second. So in 1 second the amplitude or the wavelength covered is only one. The wavelength covered is only one wave, one complete crest and trough. But in that case, suppose this is 1 second. Okay. In this case, you can count 1, then 2, then 3, and then half hour. Then 3.5 vibrations. Right? So the number of vibrations or oscillation completed by an object in 1 second. See, time period. Similarly, time period is the time taken by an object to complete one oscillation or one vibration. The time taken or the time passed by in completing one oscillation or vibration. Suppose one vibration is completed in a fraction of second, then the time period is that fraction of second. Suppose suppose 80 oscillations complete in 80 vibration completes in 1 second, then the time period of the 80 vibration is only 1 second. That is time period. Loudness and pitch. Loudness of sound is the measure of sound energy reaching our ear. That means that amount of sound which enters our ears. To measure that energy, we calculate the loudness. Loudness depends upon the amplitude. You know very well amplitude. This is the amplitude. This is amplitude. So the loudness depends upon the amplitude, and loudness is directly proportional to the square of amplitude. If we increase the amplitude, then suppose we twice the amplitude, then the loudness becomes 4 times, and if we thrice the amplitude, then the loudness becomes 9 times. Just the square of amplitude. It is measured in decibel. Decibel is the SI unit of, that is our loudness. In normal breathing, there is a sound produced only of 10 decibel. In whispering, when you whisper around 5 meter away, and then it is of 30 decibel. And normal conversation which I do with you, that is of 60 decibel. And above 80 decibels we can't tolerate it. Means it is a kind of noise which is unpleasant to us. Next, pitch. What is pitch? Pitch is the sensation of the frequency of an emitted sound. That means loudness is depend upon the amplitude and pitch is depend upon the frequency. The frequency of the emitted sound. We can calculate the pitch by the frequency of emitted sound. So the pitch depends on the frequency. If sound has more frequency, then it is highly shriller. If we say something with a high frequency, then pitch is very high. And if we say something with a low frequency, then the pitch of the sound is very low. In women and children, the pitch is very high because they have very shrill voice. It is a very important question that women or children have high pitch or low pitch, or an adult male have a high pitch or low pitch. So in that case, what happens that women and children have high frequency sound waves. So their voice is more shriller than adult male, because adult male have low pitch sound or low frequency sound. Similarly, you can see when you hit a drum or you whistle. You take a whistle and you produce a sound. A whistle has high pitch because its frequency is like that. You see? And in case of drum, when you hit the drum, the frequency is like that. And what is frequency? Is the number of oscillation in per second, remember. So in case of whistle, there is a very high pitch, the whistle has shriller sound, and in case of drum, you beat a drum that has a low shriller voice or low shriller sound because of the low frequency. Audible and inaudible sounds. Audible sounds are that sound which we can hear, and inaudible sounds are that which we can't hear. Sound of frequency range between 20 Hertz to 20,000 Hertz. We know that frequency is measured by Hertz, that is denoted by Hz. So the sound of frequency range between 20 Hertz to 20,000 Hertz are audible to us. And frequency below 20 Hertz and above 20,000 Hertz, that is frequency below 20 Hertz and above 20,000, because our range is 20 to 20,000 Hertz. So the below range and the above range to the 20,000 Hertz are inaudible sounds to humans. Although dogs and cats can hear above 20,000 Hertz. Dogs and also some animals have some that quality that they can hear above 20,000 Hertz. Now see, noise and music. What is noise? You all are familiar with that word noise and music, because that sound which we feel is pleasant to our ears, which we feel that is pleasant to our ears, that is music. And noise is that sound which is unpleasant to us, which is unbearable and unwanted sound is called noise. So this kind of sound that produces untolerating thing in our ears, or our ear feels our ear feels unpleasant. So this kind of noise is called, this kind of sound is called noise. And noise created noise pollution. What is noise pollution? Noise pollution is that thing which is due to the high shriller or high pitched sound which creates unpleasant, unbearable and intolerable sounds in our ear, due to which we feel headache. The first thing that happens to me just because of high pitched sound, suppose if I attend any party or any that is what we call sabha, there are so many loudspeakers and minister spokes in a high manner, and I usually have headache for some time. And this kind of noise pollution, if you tolerate it day by day, then it can cause insomnia, hypertension, anxiety as well as blood pressure. And you can't believe that the high pitched sound and the noise pollution can also cause death, just because of the sensation of your ears are can't bear that type of sound. That is noise pollution. So think that noise pollution is very dangerous to us. And for examples, the how noise pollution created, for like that explosion of crackers, you are very familiar, which you used to crack them on Diwali, but don't use them because they create two things: the air pollution, and the second thing is noise pollution, which is very hazardous to us. And the second is loudspeakers, the horns of vehicles, they all produces noise pollution. So students, this is my overall topic on sound, and I hope you all got the topics very clearly. Take care, bye bye, see you at the next video.